The National Electrical Code, specifically in its 2002 edition, mandated arc fault circuit interrupter, or AFCI, protection for all bedroom circuits whenever new branch circuits were installed. The critical point to understand is that the NEC requirement for AFCI protection is directly linked to the installation of new branch circuits. It is not automatically triggered simply by replacing an electrical panel board. Therefore, if the work involved only the replacement of the panel and did not include the installation of any new branch circuits in the bedrooms, the NEC itself would not have required the addition of AFCI protection. It is crucial to recognize that electrical codes are not static. They are updated periodically, and these updates can introduce new requirements or modify existing ones. The specific edition of the NEC that is in effect in a particular jurisdiction at the time of the work is what governs. For example, later editions of the NEC might have expanded the AFCI requirements to include other areas of the home or to apply to more situations beyond just new branch circuit installations. The NEC provides a baseline for electrical safety, but local jurisdictions have the authority to amend or supplement the NEC to address specific local conditions or to enhance safety beyond the NEC minimums. These local amendments can be more stringent than the NEC. This means that a city, county, or state could have a local code that requires AFCI protection in situations where the NEC does not. For example, a local code might require AFCI protection for all circuits in a home whenever a panel is replaced, regardless of whether any new branch circuits are being installed. It is essential to verify the local code requirements with the relevant authorities, such as the local building department or electrical inspector. They can provide definitive information on whether AFCI protection was required in the specific situation. The process of verifying local code requirements typically involves contacting the local building department or the electrical inspector's office. These offices are responsible for enforcing the electrical code in their jurisdiction, and they can provide information on any local amendments or interpretations that may be relevant. In some cases, the local code requirements may be available online on the building department's website. However, it is always a good idea to contact the office directly to confirm the information and to ask any specific questions. When contacting the building department or electrical inspector, it is helpful to have specific information about the project, such as the date of the panel replacement, the scope of the work, and the specific location of the property. This will help the inspector to provide accurate and relevant information. In situations where the NEC and local codes differ, the more stringent requirement always takes precedence. This means that if the NEC does not require AFCI protection, but the local code does, then AFCI protection must be installed. The purpose of this rule is to ensure the highest level of electrical safety. While the NEC may not have required AFCI protection for a simple panel replacement, it is important to consider the benefits of AFCI protection in general. AFCIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. Arc faults can occur in damaged or deteriorated wiring, loose connections, or faulty appliances. AFCIs work by monitoring the electrical current and detecting the unique characteristics of arc faults. When an arc fault is detected, the AFCI trips the circuit, cutting off the flow of electricity and preventing a fire. Installing AFCIs can provide an extra layer of protection against electrical fires, especially in bedrooms where people are sleeping. Even if the code does not require AFCI protection, it may be a good idea to consider installing it for enhanced safety. Upgrading an electrical panel can also create an opportunity to address other potential safety issues in the electrical system. For example, it may be a good time to inspect the wiring for any signs of damage or deterioration, to tighten any loose connections, and to ensure that all electrical devices are properly grounded. These steps can help to improve the overall safety and reliability of the electrical system. If there are any concerns about the safety of the electrical system, it is always best to consult with a qualified electrician. A qualified electrician can inspect the system, identify any potential hazards, and recommend appropriate solutions. It is important to choose an electrician who is licensed and insured and who has experience working with the type of electrical system that is being serviced. The NEC is a comprehensive set of standards, and understanding its requirements can be challenging. There are many resources available to help people understand the NEC, including books, articles, websites, and training courses. The NEC itself is published by the National Fire Protection Association, or NFPA, and is available for purchase on the NFPA website. There are also many online resources that provide summaries and explanations of the NEC requirements. In addition, many local community colleges and trade schools offer courses on electrical code and safety. Continuing education for electricians is also essential to keep abreast of changes in the NEC and best practices. Electrical technology is constantly evolving, and new products and techniques are being developed all the time. Continuing education helps electricians stay up to date on these changes and to provide the best possible service to their customers. In addition to formal training courses, there are also many opportunities for electricians to learn from their peers. Electrical trade shows and conferences provide a forum for electricians to share information and to learn about new products and technologies. Online forums and discussion groups also provide a valuable resource for electricians to ask questions and to get advice from other professionals. The electrical panel itself plays a crucial role in the overall electrical system. It serves as the central distribution point for electricity in the building, receiving power from the utility company and distributing it to the various branch circuits. The panel also contains circuit breakers or fuses, which protect the circuits from overloads and short circuits. When a circuit breaker trips or a fuse blows, it interrupts the flow of electricity to the circuit, preventing damage to the wiring and appliances. The size of the electrical panel is determined by the electrical load of the building. The electrical load is the total amount of electricity that is used by all of the appliances, lighting, and other electrical equipment in the building. The panel must be large enough to handle the electrical load without being overloaded. Overloading an electrical panel can be dangerous, as it can cause the circuit breakers to trip frequently, or it can even lead to a fire. Electrical panels are typically rated in amps, which is a measure of the amount of electrical current that the panel can handle. Common panel sizes include 100 amps, 150 amps, 200 amps, and 400 amps. The size of the panel that is needed will depend on the size of the building and the amount of electricity that is used. It is important to choose a panel that is large enough to handle the electrical load, but it is also important to avoid choosing a panel that is too large, as this can be more expensive. When replacing an electrical panel, it is important to choose a panel that is compatible with the existing wiring. The wiring must be properly sized for the panel and the connections must be made correctly. It is also important to ensure that the panel is properly grounded. Grounding provides a path for electricity to flow back to the source in the event of a fault, which helps to protect people from electric shock. Working with electricity can be dangerous, and it is important to take precautions to protect yourself from electric shock. Always turn off the power to the circuit before working on any electrical equipment. Use insulated tools and wear rubber gloves and shoes. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work. Arc fault circuit interrupters, or AFCIs, are an important safety device that can help to prevent electrical fires. AFCIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. Arc faults can occur in damaged or deteriorated wiring, loose connections, or faulty appliances. AFCIs work by monitoring the electrical current and detecting the unique characteristics of arc faults. When an arc fault is detected, the AFCI trips the circuit, cutting off the flow of electricity and preventing a fire. There are two main types of AFCIs: branch or combination AFCIs, and outlet branch circuit AFCIs. Branch or combination AFCIs provide protection for the entire branch circuit, including the wiring and outlets. Outlet branch circuit AFCIs provide protection only for the outlets on the circuit. AFCIs are typically installed in electrical panels, but they can also be installed in individual outlets. The NEC requires AFCIs to be installed in many locations throughout the home, including bedrooms, living rooms, dining rooms, and family rooms. AFCIs are not required in bathrooms, kitchens, garages, or unfinished basements. However, it is often a good idea to install AFCIs in these locations as well for added safety. When choosing an AFCI, it is important to select a device that is listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. This ensures that the AFCI has been tested and meets safety standards. It is also important to choose an AFCI that is compatible with the electrical system. The AFCI must be rated for the correct voltage and amperage, and it must be compatible with the type of wiring that is used in the building. Installing AFCIs is a relatively simple process, but it is important to follow the manufacturer's instructions carefully. If you are not comfortable installing AFCIs yourself, it is best to hire a qualified electrician to do the work. Electrical safety is a critical concern for homeowners and electricians alike. Understanding the requirements of the NEC and local codes, as well as the benefits of safety devices like AFCIs, is essential for ensuring a safe and reliable electrical system. Regular inspections and maintenance can help to identify and correct potential hazards before they cause problems. And when in doubt, it is always best to consult with a qualified electrician.